Alright, let's try Chapter 6, Problem 4 from the textbook. According to a statistical study, the following relationship exists between an electric power plant's fuel cost, C, and its 8-hour output as a percentage of capacity, Q. So the relationship is written as C equals 16.68 plus 0.125 Q plus 0.00439 Q squared. So for question A, when Q increases from 50 to 51, what is the increase in the cost of fuel for this electric plant? Question B and question C, whichever is similar to each other. Question B, of what use might the result in part A be to the plant's managers? Question C, derive the marginal fuel cost curve for this plant and indicate how it might be used by the plant's managers. So, as you noticed in question C, you anyway need to find the marginal fuel cost curve for this plant. So remember, marginal cost is defined as the change in total cost divided by the change in quantity of output. So you anyway need to apply the delta operation or the derivative. So the total cost, or in this case written as C, is given as 16.68 plus 0.125 Q plus 0.00439 Q squared. So when you want to see the change in total cost divided by delta Q, anyway, delta Q will appear here and here as you are changing Q. So maybe with knowing that this constant term will be 0 when you apply delta operation, you can divide both sides by delta Q without going through all the intermediate steps. Then you just need to write the derivative of this right hand side. So as you change Q by delta Q, you end up having this multiplied constant that amplify the change in Q plus 0.00439 multiply the power 2 in front and Q 2 minus 1, right? So marginal cost will be 0.125 plus 2 multiply this will be 0.00878 and Q power 1 is same as Q. So that's the marginal cost that will help you to answer question C. Alright, let's go back to question A that asks you to find the increase in the total cost when quantity Q increases from 50 to 51. So if you think that quantity can be only integer, then the change from 50 to 51 is the minimal unit you can change, or the basic unit, 1 unit you can change. So you're looking at the change in total cost when there's a change in the minimal unit of output. So you're looking at the marginal cost when quantity is at 50. So for answering question A, you can simply plug in Q equal 50 to the marginal cost function. Then you can calculate these number and find out the marginal cost at quantity Q equal 50, and you try to see the increment cost when output increase from 50 to 51. Then you'll find that incremental cost will be about 56 cents. And there's an alternative way to answer this question. If you have not found this marginal cost function, then you can see that, okay, so you calculate the difference of total cost when quantity equal 51, when quantity equal 50. So in this case, you're looking at the initial total cost function, 1668 plus 0.125 Q plus 0.00439 q square and plug 51 here, right? And do the same thing to the same function but different quantity q, which is 50, and same thing 50 square, right? So of course constant will be cancelled out, and you can see that 0.125 multiply 51 minus 50 will be 1, multiply 0.125, so you have 5150, right, which give you 1, and on the last term you have 0.00439, 51 square, 52 square, 50 square, which is 51 plus 50 multiplied 1, so about 101. So this will be 101, and multiply this, then basically you are moving this decimal point to 2 stop away. So the first term is close to 0.125. The second term is very close to 0.439. So when you add up these two, then you also find out the answer, the incremental cost, is very close to 56. So this calculation can generate slightly different answer from this calculation that uses marginal cost function, because the marginal cost function does not assume the quantity need to be integer, while this calculation we assume that quantity of increase is an integer. Okay, so in question A, we found that the additional cost increase from quantity Q equal 50 to 51 is 56 cents or $0.56. So question B asks you to find of what use might the result in part A be to the plant's managers. So question B, answer can be the marginal cost is useful for determining the profit maximizing level of output. This information will be useful if the manager finds that it is possible to expand sales at the current price and this price exceeds 56 cents. So price is the revenue per unit. Per unit revenue exceeds this marginal cost 56 when currently the output is 50, then as long as the price exceeds 56 cents, increasing output from 50 to 51 is profitable. Question C, derive the marginal cost curve for this plant. We already did it. And indicate how it might be used by the plant's manager. So here we already know that marginal cost curve has slope positive. So it's a straight linear line as you have this Q and vertical intercept of 0.125. So likewise in question B, marginal cost might be used to choose among alternative output levels. So as long as the marginal cost at each unit is less than or equal to the price for your product, it's more profitable to increase your output. Thanks for watching.